This webinar will be led by me. I'm Ivan Beryazev. I'm country manager of Russia, but I'm here not the only one. I will be here with our system architect, Oleg Tokarev, who will be there just in case if I need some help with some technical questions, if there are any. What we are going to talk about, we actually are going to cover our latest achievements in Openprovider in our infrastructure team. We will talk a little bit about the initiatives that we are launching in the infrastructure team. Also, maybe it makes sense to start a little bit with the background. So recently, we have started to practice internal knowledge transfer sessions in our development team and in other teams as well, simply because our system and Openprovider is getting bigger and bigger, and it seems there are less and less people who really understand how the system works altogether. So basically, only few people have a real helicopter view on what is going on, how the system works, and which modules exist and how they are communicating to each other. So these kind of presentations that we are starting to do in-house, they actually were intended to cover that gap. So that can also make the learning curve for newcomers of our organization easier. And also, in case of those presentations can go through the filter of the company itself, it goes for the wider auditorium. And this is actually the case with this specific presentation. We did it in-house, and actually we received quite good feedback. And that's why we decided why not to share it with the outer world as well. So yes, that's basically it about the introduction. So about the topic. So it speaks how we cook Elasticsearch, console, hub proxy, and DNS recursor. But actually, this is only one of the projects that we are running within the stability program. The ultimate goal of that stability program is to be able to deploy our services and our infrastructure on any with any service provider, basically. So we would like to become less dependent on infrastructure failures and malfunctions. So in this presentation, we would like to demonstrate actually where we are with this within this stability program, and how far we are with the investigations, and which direction basically we are going. We have started to use Elasticsearch for actually it happened more than a year ago. We are using Elasticsearch as the cache for our front end. And actually, that experience was quite successful, and we started to put more and more load on Elasticsearch. And at a certain point, we figured out that there are limitations. So when time passed, this service has become more and more critical, and we started to question ourselves how we can scale it and how can we make it more stable, basically, so we can rely it in the production environment. As I said, it become more critical, and basically it become a single point of failure at a certain point. So that resolving that task become pretty critical for us. And the next slides actually will show how our infrastructure team were thinking about the ways of resolving the problem. So you will basically see the root of their thoughts. And actually, this presentation was done by our infrastructure guys, so you see it's done in a pretty funny manner. So you will see further on, it will continue that way. So here you see Elasticsearch and how we are calling, sending calls to it. So what happened Elasticsearch go down? Yeah, it's basically a disaster. So in case if Elasticsearch becomes a critical service, which is actually our case, that is actually not acceptable, and we have to do something with it. What we decided to do? Yes, we hid the Elasticsearch behind Haproxy. So what is Haproxy? Haproxy is a free open source software that provides high availability load balancer and a proxy server for TCP and HTTP based applications that spreads requests across multiple servers. Actually, it's written in C language and it has a good reputation. So that's actually the next picture. That after that has been done, so we already could achieve the situation when one of the, for example, all the nodes of Elasticsearch cluster goes down, and it still should be able to work, but it's not it's not as easy as it seems. So here you see that Haproxy can route you to different nodes of the Elasticsearch cluster. And meters actually here, they are showing that the health of the nodes is being monitored. Also, maybe it makes sense to make a technical remark here. So Haproxy is actually needed only for simple clients, which talks to nodes to Elasticsearch via like HTTP protocol. But for complicated clients, it's not actually required. For example, for Java clients, because that kind of clients can talk to Elasticsearch directly and discover healthy nodes via Elasticsearch toolset. Okay, let's move on. So what happens here? So yeah, we built that kind of setup, and you can see that it seems like we can access our data even if one of the nodes of Elasticsearch is down. But yeah, what happens if if our Haproxy node goes down? Obviously, as you see in the picture, it is a disaster again. So and yeah, so the obvious next step that comes came actually into our mind is to add extra load balancer for redundancy. Yeah, so that's how the schema looks right now. But still, the question is still there actually. What happened if one of the load balancers goes down? And yeah, here you see what happens basically. So DNS can still point us sometimes to wrong load balancer because it knows nothing about its state, if it's healthy or not. So, but yeah, here you see that in 50% of cases it still works, but 50% of cases is still not acceptable. Yeah, when DNS gives you the wrong load balancer, it makes it great. So basically the task that you can formulate is how to make DNS forget broken balancer server as soon as possible. And yeah, the further investigation actually ended up with using additional service. Actually, it speaks about Console.io. Console.io is a distributed and highly available service discovery tool that can actually take away our headaches. So yeah, that's the next step. We decided to add here additional layer. So you see from the next scheme, so now all the DNS calls to DNS are forwarded to console cluster. And the console cluster does everything, all the his magic underneath. So console monitors services and services through its DNS interface. So console actually plays a role of a DNS server and actually gives you the IP addresses only of those balancers which are healthy. So it's in very simple words, for the outer world, console cluster looks like a DNS server. As long as we are IT people, we are quite freaky about metrics and measurements. And this is actually what we ended up with. As long as we really love working with Zabbix, and because it allows us to receive notifications on every node health and notify the responsible person via Telegram push notifications. So this is what actually does it mean? Maybe it makes sense to talk a little bit further in terms of safety loops. So basically, it means we have 3 safety loops here in the new architecture. We now have 3 levels of safety. First one is a watcher and notification center. In case of disaster, notifications are sent to everybody, including the top management. So the second safety loop is basically a load balancer, which sees immediately that the node in the cluster has failed or failed to answer, and automatically turns that off via hub proxy. And the third safety loop is actually when the node is back to work and available, it is automatically added back to the cluster, and console adds the IP of the newly added node into its DNS response. So here, obviously, with the new schema, with the new architecture, it might seem that DNS server is a single point of failure, but actually this is not the case. Actually, it's only Zabbix which is here is a single point of failure, and actually, even if Zabbix goes down, it doesn't make any impact on anyone. And even additional non-authoritative DNS servers can be deployed easily in seconds via Ansible, including changing the configs. So this is how it works in case of disaster, and yeah, you might see that it can still system can still be available in case of really something that's really bad happens. Yeah, this picture I decided to leave. Actually, it was done by our infrastructure team, and I just thought maybe someone else in the webinar would have the same freaky sense of humor as we do. So let's move on. Hub proxy. So this is yeah, more technical stuff already. This is about how we set up a hub proxy load balancer. It seems a few lines, but yeah, it took a while for our infrastructure team to get through. This is the way hub proxy has been configured, and basically it says I balance Elasticsearch nodes. I receive HTTP requests on specific port, which are routed to Elasticsearch as a backend. And also there are 3 Elasticsearch cluster nodes configured, and each node is health checked every 1000 milliseconds. And if we get 5 bad replies, it takes it away from the balancing. And if we get 10 positive or successful replies, the Elasticsearch node is getting back to the balancer. Also checks or the health checks of the Elasticsearch cluster is done via HTTP requests, and they are sent to this specific URL. And if it replies with the status red, then we definitely know that the node is not healthy anymore. So let's move on. This is how we set up our console agent. The configuration actually is pretty simple. You can see what is the name of the service and how we check its availability. So here we just check that on specific port we receive an error code to 200, which is success, which means that hub proxy is available and can reach at least one Elasticsearch node. If you check Elasticsearch cluster via dig command at console cloud, here you can see the @ sign. This is what you will see. It gives you the IPs of our proxy nodes which are available. This is the setup of our PDNS recursor. It also required a little bit of tuning. We had to make sure there is that TTL is 0, and our PDNS recursor does not cache outdated data from console, and we get only the most actual information. Here also we are forwarding zone Martishka to console. This is how our resolver config looks like. And here you see that we put 2 recursors deployed by us and 2 other recursors deployed by our infrastructure provider, and one more fallback recursor which is from Google. And once again, the picture, the final picture of the architecture, how it looks right now. Just once again to assure everybody how cool we are. Yeah, and this is again a piece of IT humor. So basically that's it. I have also a few words around our infrastructure team and where we are going. So basically the failover technique described here will be reused also for other clustered services that we are running, for example, web hosts of Openprovider, our pricing promotion module, and any other critical service. So basically the technique that we used here we are going to reuse, and basically it allows us to build our infrastructure in a very flexible way. So even based on a certain criteria, for example, the number of HTTP calls, or it can be anything, we can say that we will deploy additional node of Elasticsearch or additional node of our Openprovider backend application or whatever, and kill additional nodes as well based on a certain criteria. And this is what the console IO expertise now allow us to do. It also makes sense to mention that within this investigations, we figured out that Elasticsearch cannot handle that big amount of data. So currently we already storing there in the cluster, I think more than half of a terabyte, and we see that we have issues with that. So we have to think further on how can we scale it. So basically the idea on how we are going to use the Elasticsearch in the future, we will basically use it as sort of a front end where we are going to store only the data, for example, for the last half a year, and for the rest we are now searching for the better solution, which could be actually the Apache Cassandra. Now we are focusing on the delivering of the scalable services which can be deployed in any public cloud, where this approach can be used easily as well. This technique can allow us to put different nodes of any clustered service in a different locations, in a different data centers, which makes the whole structure pretty stable. Also, maybe makes sense to mention that the future focus of our infrastructure team will be more and more on mature and enterprise solutions, such as, for example, Apache Kafka, Cassandra, and Spark. So maybe these are the technologies that we are going to cover in one of the next webinars in the future. So that's basically it. Then let's close it. I hope it was useful, at least for someone. We can get back to the same topic later on if we receive feedbacks that maybe it requires more clarification or whatever. Okay, bye, cheers.